Hello, in this tutorial, we are learning measures of dispersion. Measures of dispersion. By the end of this tutorial, you should be able to determine the range of data sets, calculate the mean deviation, variance, standard deviation for both grouped and ungrouped data. My name is Ademola Folarin. This tutorial is powered by IOTA Virtual Learning. So let's learn together. When we say measures of dispersion, is a statistical tool that helps us to measure how scattered a set of data is. How scattered a set of data is. And some examples of these statistical tools are range, mean deviation, variance, standard deviation, interquartile range, semi-interquartile range. So let's quickly have background knowledge of it before we delve into solving problems. When we say the range tells us the difference between the largest and the smallest value. The difference between the largest and the smallest value in a given data set. So it's always like when we have the largest value, minus smallest value in a given data set. That is what range explains. Why the next is a mean deviation. Remember, we've understood the mean as the average score of a given data set. But the mean deviation is telling us how deviated are the set of scores from the mean. How deviated are the set of scores from the mean. That is what mean deviation tells us. And for this mean deviation, we can group it into two. For the grouped, let's do it this way. For the grouped data, when we are dealing with group data, and when we are dealing with ungrouped data. The mean deviation, abbreviated as MD, for grouped data is a summation of frequency multiplied by the absolute deviation. Absolute deviation, the deviation is each score subtracted from the mean score, all divided by total number of score, n. That is for the grouped. For ungrouped, the mean deviation for ungrouped is a summation of absolute deviation, divided by the total frequency, which is n. So this formula is what we use when we are to calculate the mean deviation for grouped, and this is what we use for ungrouped. Also, the variance. The variance itself is another measure of dispersion. The variance is a measure of dispersion that tells us the average of the squared deviation from the mean. The average of the squared deviation from the mean, that is what we call the variance. The average of the squared deviation from the mean. And the way it's calculated for the grouped and ungrouped is quite different. So for the grouped data, the variance is summation f, the absolute, or this that we call the deviation, x bar all squared divided by the number, which is the total frequency. And for the ungrouped data, the variance is summation this. So we don't really need to multiply this by frequency since we are dealing with just the ungrouped data. So summation absolute of x minus x bar all squared divided by total frequency. So the mean deviation, this is the formula for the group data, and this is the formula for ungroup data. Variance is this. So the next is our standard deviation. The most important part are the ones we've discussed here. The standard deviation is the square root of variance. Standard deviation is the square root of variance. Once we know this, it is always easy for us. Standard deviation, the square root of variance, which is equals to square root of all that we have here, either the variance of group data, if you are dealing with group data, if it is on group data, if you are dealing with ungroup data, so it's basically square root of summation f, the absolute of x minus x bar all squared divided by n. This is for ungroup data. And many more that we can think of. Going further, the quartile and interquartile range, those ones, the quartile part is talking about when you divide a group of data into 4. So the interquartile range that we call Q, interquartile range, let's quickly have interquartile range. Remember, we discussed range as the difference between the largest and the smallest. So interquartile range is the difference between the third quartile and the first quartile of a given set of data. So we say Q3 minus Q1. When you divide your set of score after ordering it, when you divide it into 4 quartile, so the difference between the third quartile and the first quartile is what we call the interquartile range. Now we have this idea. Let's understand that the measures of dispersion are so important because they help us to compare variability between 2 or more data sets. They also give us understanding of how consistent our data is. They tell us how deviated are our data set from the mean of the data set. Now, understanding all this formula, let's take a look at problem around it. The very first question here, the question says we should determine the range, the mean deviation of this data score. When you look at this now, this is a data set from ungrouped class, that is the discrete data set. So we are asked to find score of 5 students here. There are things we must take note here. The n here is 5. That is the total frequency. So let's take it one by one. Number 1, we are to determine the range. Recall, to get the range is the difference between the largest and the smallest. So the range is equals to 10 minus 4. That means the range is equals to 6. That is the range for this 6. Then the next is for us to determine the mean deviation. To be able to get mean deviation, we'll first get mean. We get mean. So let's quickly determine the mean of this data score. The mean is done by saying addition of all these data sets, that's 4 plus 6 plus 7 plus 9 plus 10, all divided by 5. And if we do that, adding this together, so that means our mean is equals to, when you add all this together, that's 10 plus this, that's 20, and this make it 36. So we have it as 36 divided by 5, and that will give us 7 point something. That's x is equals to 36 divided by 5, 7.2. That is the mean. Now that the mean is 7.2, to easily get the mean deviation, we'll do something. Let's quickly create a table to help us find out the dispersion, the deviation. So from that table, all we need is a score. We also need the area for the deviation. We also need the absolute value. In this table, we do not need the frequency, since all of this score given to us, they are just 1, 1, 1. So what we need here is the score, which is regarded as x, and we need deviation, which is each score minus the mean, and we need absolute value of the deviation, x minus x bar. So going forward now, each score we have it as 4, 6, 7, 9, and 10. So what is the x minus x bar? It means each score we subtract the mean value from each score. So here we have 4 minus 7.2. That gives us minus 3.2. If we try it here, it's going to give us minus 1.2. If we try here, it's going to give us minus 0.2. Then if we say 9 minus 7.2, that gives us 1.8, and this gives us 2.8. Now that we've done this, what we just do is take the absolute value of all these data sets. By taking the absolute value, we'll lose all the negative. That is to help us cater for the negatives. So that will be 3.2, 1.2, 0.2, 1.8, and 2.8. So we then determine the summation of this absolute value. The summation of this absolute value, x minus x bar. The summation of it is by adding all together 3.2 plus 1.2 plus 0.2 plus 1.8 plus 2.8. So whatever that gives us, which is all together, it gives us 9.2. 9.2. So here we can then say the mean deviation. Let's part this. Then the mean deviation from this mean deviation MD is equals to summation absolute of all this divided by n. Remember, and that is 9.2 divided by what is the value of our n? 5. That's the total frequency. So which this is going to give us 1.84. That is the mean deviation. Mean deviation is 1.84. Now that we've gotten mean deviation, what next is our standard deviation? Remember, we've established the formula. For us to do standard deviation now, we need x minus x bar square. The square of all the values that are here, we need it for our standard deviation. So let's quickly compute for the square of all the value that we are here. 3.2 multiplied by 3.2, the square of 3.2, that's 10.24. We also find the square of 1.2, that's 1.44. The square of 0.2, that's 0.04. Then the square of 1.8, that's 3.24, followed by the square of 2.8. 2.8 times 2.8, that gives us 7.84. So let's rearrange this. This is to help us get the total here. So from here, the summation here is 9.2. Let's look at the summation here. 10.24 plus 1.44 plus 0.04 plus 3.24 plus 7.84 all gives 22.8. That's 22.8. So in this, it tells us that the standard deviation SD is equals to square root of summation square of deviation divided by n, and that gives us square root of, what's the square of deviation? 22.8 divided by 5. And when we do that, that's square root of 22.8 divided by 5, that gives us 4.56, and the square root of that, square root of 4.56 is 2. Therefore, standard deviation is equals to 2.13 for this data set. And that is a simple approach to determine the range, the mean deviation, and the standard deviation for ungrouped data, just as we have it here. Interesting, right? Good. So let's consider if what is given to us is a group data. If what we have is a group data, such as this, we want to deal with group data in this manner. We are asked to calculate the mean and the standard deviation. Now you already know, when you are given this set of data and you have to calculate the mean and the standard deviation, because we need standard deviation, we can think of set of values that we are going to need, or things that are needed for us to calculate the mean. Is quite simple for this. Remember that we must learn something. Mean for a group data, mean, which is the x bar, is equals to the summation of fx divided by the summation of f. So here, from this, we can understand that there are things we will need. We will need the x. Let's extend this table so that it can cater for all those things that we are going to need. So we need the x mark, that's the middle mark, we need it. We also need fx, the column for fx, the product of frequency and score. We also need the deviation column. We need the column for square of deviation. The column for square of deviation, let's make it bigger. And we need the column for the frequency and square of deviation. So let's quickly fill in all those parts. This is going to be the X, the class mark, the column for X, we need it. We need the column for Fx, the product of frequency and score. We need the column for deviation, that's X minus X bar. We need the column for square of that deviation, that's X minus X bar squared, the square of it. And we will need the column for frequency multiplied by the square of the deviation. Now that we are convinced about all this, then let's take it further. To determine the score, which is the middle value, we are going to say X for each of it is going to be the upper limit plus the lower limit divided by 2. By upper limit, we mean the value here. By lower limit, we mean the value here. So this one now, what we have here, the upper limit for the first one is 64. That's 64 plus the lower limit, which is 60, all divided by 2. And when we do that, that's 124 divided by 2, and that will give us what? 62. So that's the mid value for it. We'll get 62. Let's put that there. So X is 62. For the second one here, we do the same thing, and we are going to get 67. If we do the same thing here, we get 72. Once you have done this, it can easily be transferred down here. This one is going to give us 77. And the next is going to give us 82, followed by 87. Here, 92, followed by 97. Now this is done. We then look for the product of the frequency and the score, Fx. We multiply it. When we multiply the frequency and the score, for this, we are going to get 124. Here we get 201. Here when we multiply, we get 432. And 77 multiplied by 11, we are going to get 847, followed by 656. And when we multiply 7 and 87, that should give us 609. When we multiply 92 and 2, that's 184. When we multiply 1 and 97, that gives us 97. So all this now, you find the total sum of this. In this situation, we'll do something interesting. Find the total sum of this. The total sum of it gives us 3150. So for easy part of it, I will just keep all those scores around here. 3150. After adding it together, that means our summation Fx is equals to 3150. So now that we've gotten summation Fx, we can then come back to our mean. That means the mean is equals to summation Fx 3150 divided by the total frequency. We need to look at this total frequency. 2 plus 3, that's 5, 11. Add this together, that's 22. Add this, that's 30, and this is 10. So making it 40. Frequency, the total frequency, our F, summation F is equals to 40. So that means divide this by 40. Hence the main score is equals to 78.7 5. That is the mean score. Now that we've gotten the mean score, we can now look at deviation of each score from the mean. Deviation of each score from the mean. We want to look at how deviated each score is from the mean. To do that now, you subtract the mean from each score. Subtracting the mean from each score, that is 62 minus 78.75. That's this deviation. When you subtract, you get minus 16.75. If we do it for the second one, we have minus 11.75. When you subtract 72, we subtract the mean from 72, we have minus 6.75. Subtract it from 77, we have minus 1.75. Subtract it from 82, we have 3.25. Here we have 8.25. Then subtract it from 92, we have 13.25. Subtract it from 97, we have 18.25. After deviation is known, we can then go for the square of deviation. The square of deviation is going to be that we square each of this number. So to make it easier, we do square this. You are going to get 280.5625. Just pick it in that way. Then do the next one. We have 138.0625. We do the third one. That's 45.5625. The fourth one, when we square 1.75, that gives us 3.0625. And when you square this, that gives you 10.5625. When you square 8.25, you have 68.0625. When you square 13.25, you have 175.5625. And lastly, we have 333.0625. That is the deviation. When that is done, the next thing is now to find the square. This square of deviation multiplied by the frequency f. This is our f frequency. Multiply the square of deviation by this for each set. So this one gives us 561.125. The second one gives us 414.1875. The third one 273.375. What we are doing again is that we are multiplying this by the frequency. So you multiply 11 by 3.0625. That gives you 33.6875. Multiply this by 8, that gives you 84.5. Then multiply this by 7, that gives you 467.4375. Multiply this by 2, that gives you 351.125. And lastly, multiply this by 1, it gives you back the same value, 333.0625. Now what we need to do is to find the summation of this. Find the summation of this fx, find the summation of the square of deviation and frequency. Let's add all these together. So upon adding all these together, you should get 2518.5. So let's also put that here. That means summation of fx minus x bar all squared is equals to 2518.5. Now that this is known, we move to answering number 2 question. For the number 2 question, let's remember we are asked what is the standard deviation. So standard deviation is equals to square root of variance. So this, by square root of variance, we mean standard deviation is equals to summation f x minus x bar square, that is summation of this to summation of the frequency. So which gives us the square root of, let's put in the score, 2518.5 divided by the total frequency, which is 40, and that gives us 62.9625. And if we find the square root of this 62.9625, so you also, I want to believe that we are working together, you confirm it from your own end. 62.9625 gives us 7.9348. Therefore, the standard deviation for this given data set that we have here can be approximated into 7.93, since the question says correct to 2 decimal places. And by so doing, we've been able to successfully walk ourselves through how to determine the standard deviation, the mean deviation for any given data set. Remember, the standard deviation is the square root of variance. So if the question asks you to find variance, all what you need to do is just to do this without doing the square. So take note what you need to know for each of the formulas so that you can know how to design your table. Oftentimes, the standard deviation always requires that you design your table so long like this, because you will get this and some other things. You can come across, maybe at your study time, you see where they say the standard deviation is the square root of f d square, that's summation f d square over summation f. It's still the same thing. The d in statistics is the deviation of score from, deviation of each score from the mean. Deviation of each score from the mean. So instead of where we have this, some scholars may use this and they will use this instead of all this. So it still work. One thing is, whatever formula you want to stay glued with in statistics, stay glued with it, and you find it so interesting to deal with. If you enjoyed this, don't forget to subscribe to our channel. Click on the like button for more notification of interesting mathematical concept like this. Till we come your way next time, my name is Ademola Folani. Keep learning.